What if you were told that everything you know, your memories, your world, the very fabric of reality itself, is just one thread in an unimaginably vast tapestry? What if our universe, with its billions of galaxies and laws that govern every atom, is only a single bubble floating in a boundless cosmic sea? Tonight, let's embark on a journey beyond the edge of our cosmic horizon. We'll dive into one of the most mind-expanding ideas ever conceived by science, the multiverse. As we voyage through the mysteries of space and time, we'll ask a question that challenges our place in existence. Are we one of infinite universes? The multiverse is a theoretical framework that stretches our imagination to its limits. At its heart, it is the suggestion that our universe, with its familiar stars, planets, and physical laws, is not alone. Instead, it is one of many, perhaps an infinite number, of universes that exist in a grand cosmic ensemble. Some of these other universes might be almost indistinguishable from our own, governed by similar laws of physics, where galaxies form, stars shine, and perhaps even life arises. But others could be radically different, with unfamiliar forces, different numbers of dimensions, or constants of nature so alien that matter as we know it could not exist. But what exactly is the multiverse? Why would scientists seriously entertain such an idea? To answer that, we first need to understand the basic premise. In its simplest form, the multiverse hypothesis proposes that our universe is just one region in a much grander reality, a reality that contains many such regions, or universes, each with its own unique properties. These universes may never interact with each other, or they might occasionally brush up against one another in ways that leave subtle fingerprints on the cosmos. In some versions, the multiverse is like a vast cosmic foam, each bubble representing a universe. In others, it is like a stack of sheets, with each brain representing a universe embedded in a higher dimensional space. But why would physicists, who are trained to be skeptical and to demand evidence, take the multiverse seriously? The answer lies in the strange and often counterintuitive discoveries that have emerged at the frontiers of physics, especially in our quest to understand the earliest moments of the cosmos, the bizarre realm of quantum mechanics, and the mind-bending possibilities of string theory. Let's begin with the story of cosmic inflation and the bubble universe theory. In the earliest moments after the Big Bang, the universe underwent a period of explosive expansion known as cosmic inflation. During this brief epoch, space itself expanded faster than the speed of light, smoothing out any irregularities and setting the stage for the universe we know today. This theory explains why the universe appears so uniform on large scales, and why the cosmic microwave background, the afterglow of the Big Bang, looks almost the same in every direction. But inflation, as originally formulated, had an unexpected consequence. According to many models, inflation is not a one-time event. Instead, it can happen again and again, in different regions of space. Picture a pot of boiling water, with bubbles forming and expanding everywhere. In the cosmic analogy, each bubble is a universe, born from its own burst of inflation. Our universe is just one such bubble, floating alongside countless others in a frothy cosmic foam. What's even more astonishing is that the laws of physics in each bubble universe could be different. The values of fundamental constants, such as the strength of gravity, the charge of the electron, or the speed of light, might vary from one bubble to the next. In some bubbles, stars and galaxies might never form. In others, the chemistry of life could be impossible. And in a rare few, conditions might be just right for complexity, for biology, and perhaps even for consciousness to arise. This is the bubble universe theory, a vision of cosmic inflation that produces an endless multiverse, with each universe expanding and evolving independently. Our universe, with its life-friendly properties, is just one lucky bubble among many. But the story doesn't end there. The quantum world, with its strange logic and probabilistic rules, offers another path to the multiverse. In the realm of quantum mechanics, nothing is certain until it is observed. Particles exist in states of superposition, occupying multiple possibilities at once, until a measurement forces them to choose. But what if, instead of collapsing to a single outcome, the universe splits? One copy for each possible result. This is the extraordinary claim of the many worlds interpretation, first proposed by physicist Hugh Everett in the 1950s. According to this view, every quantum event is a branching point. Each time a particle could go left or right, the universe splits, creating two parallel realities, one for each possibility. In one universe, you decide to go left. In another, you go right. In one, you pass the exam. In another, you fail. Every choice, every random event, sends reality branching into a dizzying tree of alternate histories. In this vast multiverse of possibilities, every version of you that could exist does exist, somewhere. There is a universe where you became an astronaut, another where you never learned to read, and another still where you are listening to this narration, pondering the nature of existence. The many worlds interpretation does not require any new laws of physics, just a radical rethinking of what quantum mechanics already tells us. But these universes, according to the theory, do not interact. They are mathematically implied by the equations of quantum physics, but forever separated, like ships passing in an infinite night. Still, the idea is both exhilarating and unsettling. Every outcome is real somewhere. The universe is not a single, unfolding narrative, but a branching, ever-growing tree of possibilities. If quantum mechanics opens the door to a multiverse of possibilities, string theory takes us into an even stranger realm. One where the very fabric of reality is woven from vibrating strings, and our universe is just a three-dimensional brain, floating in a higher dimensional space. String theory is an ambitious attempt to unify all the forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, into a single framework. To do this, it posits that the fundamental building blocks of reality are not point-like particles, but tiny, vibrating strings of energy. The way these strings vibrate determines the properties of the particles we observe. But for the mathematics to work, string theory requires extra dimensions, up to 10 or even 11 in some models. Most of these dimensions are hidden, curled up so tightly that we never notice them. But in some versions of the theory, there are large extra dimensions, and our universe is like a membrane, or brain, floating in a higher dimensional bulk. If this is true, there could be other brains, other universes, existing parallel to ours, just a fraction of a millimeter away, but forever hidden from view. Some models even suggest that collisions between brains could trigger new Big Bangs, creating new universes in the process. Our universe could be the aftermath of such a cosmic collision, one event in an endless cycle of creation and destruction. The idea that our universe is just one brain among many is both mathematically intriguing and philosophically profound. It suggests that the multiverse is not just a figment of imagination, but a consequence of the deepest laws of nature. But if the multiverse is real, can we ever hope to detect it? This is one of the greatest challenges facing physicists today. By definition, other universes, if they exist, are separated from ours by vast gulfs of space, time, or even higher dimensions. Direct contact seems impossible. But scientists are clever, and they look for indirect clues, subtle fingerprints that might betray the existence of other universes. One such clue is the cosmic microwave background, the faint afterglow of the Big Bang that fills the universe with a sea of microwaves. This radiation is remarkably uniform, but there are tiny fluctuations, hot and cold spots, that reveal the seeds of galaxies. Some physicists have speculated that unusual features in the microwave background, such as unexplained cold spots, could be the result of collisions between our universe and another bubble universe in the distant past. Another avenue is the search for gravitational wave echoes, ripples in space-time caused by cataclysmic events. If our universe has ever collided with another brain, it might have sent out a distinctive pattern of gravitational waves, which we could, in principle, detect. Scientists also study the large-scale structure of the cosmos, searching for alignments or anomalies that might hint at influences from beyond our universe. While none of these clues are definitive, they keep the hunt alive, driving ever more sensitive experiments and ever deeper explorations. But even as we search for evidence, the multiverse raises profound philosophical and existential questions. What does it mean if we are not unique? If every possible version of you exists somewhere, what becomes of free will, of individuality, of meaning? If the constants of nature are just random values in a cosmic lottery, does that diminish the wonder of our universe, or does it make our existence all the more precious, a rare jewel in an infinite sea? Some thinkers embrace the multiverse as a solution to the riddle of fine-tuning. Our universe appears exquisitely balanced for life. The strength of gravity, the properties of atoms, the chemistry of carbon, all seem to fall within a narrow range that makes complexity possible. In a multiverse, this is not surprising. Most universes are sterile, but a few, by chance, have the right conditions for life. And it is in those rare universes that observers like us arise to ask the question. Others see the multiverse as a challenge to our deepest intuitions. If there are infinite versions of you, does anything you do really matter? If there are infinite universes, each with its own history, is our story just one among countless others, insignificant in the grand scheme? And yet, the multiverse also elevates the human quest for knowledge. To even ask these questions is to step beyond the boundaries of what we can see and touch, to use logic, mathematics, and imagination to reach for truths that may forever lie beyond our grasp. It is a testament to the audacity of the human spirit, to our desire to understand not just our world, but all possible worlds. Could advanced civilizations exist in other universes, following different laws of physics, evolving along paths unimaginable to us? Could there be universes where consciousness takes forms we cannot conceive, or where the very notion of life is meaningless? The multiverse invites us to ponder not just what is, but what might be. And so, we are left with a cosmic mystery. Are we alone, or are we one among infinite universes? The answer, for now, eludes us. But the journey, the quest to find out, enriches our understanding of reality and of ourselves. As we come to the end of our exploration, let us reflect on the awe-inspiring possibility that we may be a single universe in an eternal cosmic archipelago, a lone island in an infinite sea. Or perhaps we are truly alone, the only universe that ever was or ever will be. Either way, by daring to ask these questions, we push the limits of imagination and science. We stretch our minds to encompass the vastness of all that could be, and in doing so, we find new meaning in our own existence. Tomorrow, we return home. We narrow our gaze from the infinite multiverse to a single, fragile world. A pale blue dot orbiting an ordinary star, in an unremarkable corner of a single galaxy. There we will explore Earth's place in all this, and ponder our own journey through the cosmos. Join us for Day 10, the pale blue dot, our fragile place in the universe. Only on Khanh Bosa Space A.